Kathy, we leave it to you to bring us our third and final presentation.
Yeah, I think what's so amazing to me, and just following along David's and Hiroshi's presentations, is how much we are doing this as one. Everybody always asks me, how is this exploration process different now than it was in the 60s? And it's mission, our science mission directorates and our human mission directorates, and we are collaborating together to maximize the benefit to all of us. Next slide. So just as Hiroshi and David talked about, we within NASA are also learning from our science missions, but within the Human Exploration Division, we're also maximizing the use of each of the platforms that we're developing, and hoping that our science mission directorates and our technology mission directorates are able to use these platforms to their fullest. And so obviously the International Space Station is a major collaboration for us, and we are continuing to use it, pushing and hoping to use it all the way through 2030, working towards extending that right now. And we'll be using it to further define and test out our systems that we need for us to accomplish our lunar missions, and make sure that our systems that we have developed and are expanding on for our Mars missions are also being used. We're also laying in an ability to be able to have a LEO platform post-ISS extension to be able to continue. We know that, for example, our ecosystems currently are being tested on the ISS. We have the ability to reclaim 93% of our water on the ISS right now. We're moving towards having that be 98%. As we're moving, and even gain even better efficiencies as we're moving towards a Mars mission. That means we're going to have to continue to evolve that ECLETS technology and be able to so that we can accomplish those hard missions that we'll be gearing towards. That will help us be able to test out across our multiple platforms to be able to get to the moon quickly and sustainably, and then deliver even more missions, more science, more technology, and more innovation at a better value for the American taxpayer. All this is about making new discoveries and expanding our human knowledge and pushing our human presence deeper into the solar system. And through that process, being able to return benefit to the Earth. Next slide. So we talked about the different platforms. We actually, obviously have our low Earth platform that is ISS right now, and continue to expand it. We're moving and have in process our lunar platform, cislunar platform, which is the gateway system. And we're looking at the things that we need to be testing out on our low Earth platform that also need to be checked out on our gateway platforms. What's really important is that we've used kind of the systems and the processes and the agreements and our international processes in place to be able to learn about how to operate in the low Earth platforms, and then are applying that to how we're going to be operating together on our cislunar gateway platforms. This is very important because we're also laying the foundation for how we're going to be working together with the Artemis Accords on the lunar surface. This isn't the snazzy part of things, but it's very, very important for us to learn how to live and work and share data together to get ourselves ready to be able to operate responsibly on each of these platforms on the lunar surface, and then be able to operate together on Mars. This is a very, very important part of us working together and doing research and science together as an international team. Next slide. We're laying the foundation right now for the key systems that we're hoping we all will be able to use together for us to do our deep space exploration. So right now our crew transportation system is in play, and we're getting ready to do the uncrewed demonstration of our Artemis 1 crew transportation system. We are working with ESA and JAXA and our CSA counterparts on getting our cislunar gateway systems through development, and then beginning to work the launch sequences for those systems. And we're in the process of doing our initial human landing system demonstration and putting in the contracts that will deliver our human landing systems going forward. But there is so much more that we need to do from a science and technology and continued lunar system collaboration to get us ready to be able to have the capabilities on the lunar, on our lunar surface, to be able to test out the systems that we need and to be able to have tested out to be able to go to Mars. In addition, our lunar surface will be able to, these, we obviously need to be able to figure out how to do in situ resource utilization. That's going to be a key feature for us to be able to have in place to be able to conduct our Mars missions as efficiently as possible. We're going to have to figure out, just like we had to learn with Mars Perseverance, we had to figure out how to get samples in an efficient way. Those will be the kinds of things that we'll be learning as we're doing lunar surface activities with humans and through robotic endeavors to help us more efficiently conduct the science and research. So in addition to the things that we've all talked about, just doing our aggregation and the way we do our aggregation, and the planning for our aggregation, the orbits that we picked around the moon are the orbits that will more efficiently get us ready to go to Mars and have the capabilities for us to be able to buy down risk in key areas to get the team being able to conduct operations, do aggregations, work in an integrated manner that will be critical for us to be able to accomplish our Mars missions. Figuring out how easy logistics supplies and work through that with a lunar analog, and there'll be tremendous learning for that for us to then get ready to the complexity of what those human Mars missions will be. Crew health and safety. We've got to figure out how to make sure, and David talked about this when he was talking about having crew members and learning, and everybody does have a disability. It's actually the great equalizer of being in space. We're going to have to figure out how to keep our crews healthy, and in a place where the first answer may not be go back to Earth. Right now, we have the luxury of, when we're in LEO, all of our contingency planning, everything else says, if there's a really bad problem, we just jump in the spacecraft and go home. We're going to have to be learning the capabilities that we need to be able to keep our crews safe and have mitigations in place. That's going to be in a really, really tough and a long mission. David talked about this. This is also the kind of learning, though, that helps us here on Earth. There are tough places where people live and don't have easy access to medicine or food or some of these other critical things that we're going to have to figure out how to deal with as we're doing our lunar missions and going to Mars. And so to me, this is another area where as we're solving that hard problem, and that we need to be able to do our exploration missions that we have, we're continuing to buy down specific risk areas that we also have here on Earth. On the surface, we haven't really done these kinds of surface activities on another surface except for Earth. Obviously, we do lots of analog missions here on Earth to check our systems out, which is a key test laboratory for us here. But we have to be able to go on a lunar surface, be able to test out integrated crew operations, and be able to have our EMUs, our EVA suit capabilities, be able to deal with the issues that you have with dust mitigation as you're going in and out of different capsules and capabilities. These are all really, really, really tough things to do. They'll be tough for us to do on the surface of the moon, but it'll be important for us to be able to do that and be able to check out those systems and continue to use the people and our robotic capabilities there to be able to further learn about the moon, but also get us ready to be able to do this, what will be a tremendously tough mission to send people to Mars. I love the imagery that David had about, we have this great like museum capability here. It's like this access to the moon, and we'll be able to use the moon and be able to learn about the moon even more with us also conducting these missions and getting us ready as to be able to then do the next jumping off point for us to go to Mars. Next slide. How little we look when you're on Mars, and just like when we're on the Earth and we look at Mars, what that looks like. And so it's just a little taste of how far people are going to be from home when we're going to Mars, and the difficulty we'll have to be able to get there. And it's going to take some learning. It's going to take some tremendous learning. But I firmly believe that we will do that learning together, and it will be learning that will help all of us as we're moving towards our bigger goals as a planet. Thank you.
Thank you, Kathy.